Finally, let's try and solve problem number 4, the last problem. So let's just try and figure out what this is about. Use the example 3 on page 103 as inspiration for implementing your own generic iterative method for finding the fixed point of a user-specified function. Okay, so it seems we should be a little bit creative. Make sure to print out the iterative value in each iteration with 20 decimals and add stop criteria that holds the iteration when a maximum iteration count is reached, or if the new iterate value is too close to a previous iterate value. So we need at least one tolerance and one max count and some printf stuff. Test your implementation of a function blah 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 blah. Use x equal 10 as initial guess. Find the solution to within 1 of e minus 5, so that's like 5 decimals. Hint, try plotting before solving problem. Okay, so as always, start out by restart. We know the number of digits should be 20. No, it's just the output of decimals, so no need to change the number of digits here. Let's do the hint first, so let's make an expression for this function. Let's copy paste it. We're lazy. It's like this. Looks okay. Yeah, cool. And we probably need this as a input sometime later, so we'll just do the usually on apply magic. It's extra simple, and we can make a plot now. And let's see, we want to have the f expression and x equal to, I don't know, minus 50 to 50. No clue. Let's just try and see how it looks like. Okay. So a fixed point should cross a line going through 0.0 with slope 1. So maybe we should plot two things here so we can get an idea of what kind of solutions we would be looking for. So let's plot the function x and the function f expression. Okay, so we actually have two fixed points. There's a fixed point here and one here. So given x equal to 10, go up here. I'm probably gonna end up with this root over here. Okay, so this was the hint. So now we have an idea of what we're gonna do. So let's start sketching out procedure for this. So we're gonna have an initial guess. We're gonna have the function we're gonna look at. We need a tolerance to determine if two iterates getting close to each other, and we need iteration maximum. Probably should make these keyword parameters so we are sure they always are defined in some sense, like this. Okay, and we're probably gonna need a iteration counter somewhere. Like this, do and do. And then we're gonna do an update in here. So we're gonna compute a new, let's call it set1 equal to f of set0, like this. Then we're gonna create a local set0. I'm gonna initialize this to x0. That should be okay. We're gonna have a local set1. Okay. Then we need to test if absolute value of set1 minus set0 is less than epsilon. Then we will return set1. Okay, like this. And if we're gonna give up, we're just gonna return whatever set1 was when we gave up. And if you continue for the next iterate, we need to make sure that set0 is going to be updated to set1, otherwise we are not ready when we go into the next for loop here. And it seems I forgot to increment the iteration counter like this. Let's see, I think most of it is in place. Stopping threshold, iteration counter increment, incrementing counter test here, update here, making sure it's ready for this. We need some printout stuff too, I think. So we need a printf. So I'm gonna write out the iteration count. You're gonna write out the current iterate value. Like this. And I think we needed to do that with some 20 decimals. So this is a float. Like this, and 20 decimals. Like that. And we'll also just make a printout. We're running out of iteration, that's always good to know. Oops, like that. New line there. And some new line up here. Let's see if Mabel likes what I've been doing so far. It seems I have an error, semicolon missing. Let's try one more time. Looks okay. Let's kill the output. And then let's try and invoke this method on our problem. My fixed point, we need to start with restart iterate of, let's see, 10, and we need to use the function, and we need to have 5 decimals, or a threshold of 5, and let's just test it with a few iterations to start out with. Let's see what goes on here. There's something wrong. So it appears it has an image, probably look like this. No, this was not it. Let's see if this works. No more iterations. Okay, let's crank up to 5. No more iterations. Let's crank up to 10 and let's kill the output. Okay, it seems to getting better. Let's don't be too eager. 30. Okay, and it seems we are converging at iteration 17. See, 1, 2, 3, 4, 5. That looks okay. So that seems to be it. Let's just check. Yes, we found that. We use this, we use that one. It's generic. We are using 2 stop criteria. We are making the output. So this is done.